you can still see the numbers. All right. So tangent of inverse sine of v. Okay, so first thing I have to do, take the inside trig function, and what did I set it equal to last time? I set it equal to theta. And now I rewrote it, getting rid of the inverse trig. So what would I have to take on both sides here? Take the sine on both sides. Sine, take the sine, and you're left with v equals sine of theta. Now you have to turn that equation into a picture. Okay, you can put theta wherever you want. Put it at the top, put it at the bottom. It doesn't matter. What does matter is that you label the sides correctly. So sine involves which two sides? Opposite and hypotenuse. So we have to label the opposite and label the hypotenuse so that when you divide them, the sine equals v. So how could we label the opposite and the hypotenuse?
Hypotenuse be 1.
Yeah, you could make it 1, you could make it 7, you can make it anything you want, as long as when you divide, you get v. But 1 is the easiest. And what about the opposite side? V. Now you've just created a diagram where the opposite over the hypotenuse is equal to v, where the sine equals v. And now, how would I get my third side? Yeah, and it's really going to be the same thing we just did last time. But if you want to go through it again, you can. So we've got v squared plus a squared equals 1 squared. Subtract the v squared, and then take the square root. So that's the pattern that I said comes up a lot. Okay, so that's 1 minus v squared. Okay, now I've got my diagram all sketched. I'm going to go back up and see what they wanted me to find. They want tangent. So look at your diagram and take the tangent of your diagram. So tangent we haven't done yet. What's tangent? Opposite over adjacent. Opposite over adjacent. So it's v divided by the square root of 1 minus v squared. Now, one thing they might do here is generally they don't leave square roots in the bottom. So you can multiply top and bottom by the square root. If you did that, you would have this. V times the square root of 1 minus v squared over 1 minus v squared. That's how you can fix it and not leave the square root in the bottom. Multiply the top by square root 1 minus v squared, multiply it in the bottom. When you multiply it in the bottom, the root just disappears. Any questions up? Okay, this time what I'm going to do is I'm going to graph what's on the left in y1. I'm going to put one of the ones on the right in y2, and I'm going to see if the pictures look the same. If they do, then that probably means I did it right. If they look totally different, then that means what you have on the left and what you have on the right are not the same, and you did something wrong. Let's use this calculator. A little older, but it'll work. So I'm going to plug in the tangent of the inverse sine of v. So tangent of inverse sine. I can't use v, I have to use x. There's the first one. And for the second one, I think it's going to be easier for me to type it in the first way. That's less stuff to type. So it's x divided by the square root of 1 minus x squared. Okay, so what we're looking for is that these two graphs look the same. Let me turn off the scatter plot. We don't need that on. And what I'll do, since I can't show you different colors on here that they look the same, is I'll draw the second one thicker. So you'll see it trace the first one. And then if the second one traces over it in the same spot, you'll see it just getting bold. So let's zoom in and see what happens. Yeah, I think you can already see it works. But if I zoom in a little bit, there's the one on the left. And there's the one on the right, tracing exactly over it. Just made it bold so you could see the difference. Okay, so that means we did it right.
So when you did the graph, you did not the final answer, but the other one with the square root at the bottom?
Yeah, I just did that because it was less stuff to type.
It's the same thing?
It's the same thing. Yeah. You could type the one on the right, but I would need more parentheses. And
so if we wrote our answer like that, like the one on the left, would it be wrong?
If they say not to leave the square root in the bottom, yes. Yeah. If they didn't mention that at all, then you could leave it however you want. Okay. And if it was a multiple choice question and you got this as the answer, you would have to know that is the same thing if you're matching them up. Okay. Any questions on that one? So you can pretty much do this kind of problem with anything where you have a regular trig function on the outside, sine, cosine, tangent, secant, cosecant, cotangent, and then an inverse on the inside. Okay, so this is regular on the outside, inverse on the inside. Let's try this one. So this one is regular on the inside, inverse on the outside. Right, so what I'm going to do this one, if they ask you to do it without a calculator, then the angle right here has got to be a multiple of 45 or 30. You can't do this in your head unless that angle is a 45 or a 30. So I'm going to focus on, just like I did last time, I'm going to figure out what that is first. And then I'll worry about inverse sine. Okay, so the tangent of 3 pi over 4. Let's start with 3 pi over 4. Just to get an idea of what this looks like in our head. What's pi over 4 in radians? Oh, that's radians. What's pi over 4 in degrees? Caitlin, do you remember? Pi over 4 is?
45.
It's 45. This is triple 45. So what's the angle I'm working with here? Yep. I'm working with a 135. Now, there's a couple ways you can do this, but if you don't have the answer memorized, which I'm guessing most people don't know the tangent of 3 pi over 4, you have to draw a sketch using circle, using a unit circle. Okay, you've done this before, so I'm just figuring out what the tangent of 135 is. Okay. If this is a unit circle, bless you, that means that the radius is 1 unit in each direction. Okay, 135, that's 90. That's 180, 0, 270. 135 is exactly halfway between 90 and 180. Okay, so we're going to draw our unit circle triangle. I think this is from 6.2, okay, chapter 6. It's the first section that we did after the material on the midterm. Midterm ended at 6.1. This is the first thing that'll be on the final. So we've got our triangle. Anybody remember the length of the two sides in a 45, 45, 90? It involved the square root of a certain number. Yeah, it involved the square root of 2. Specifically, it's root 2 over 2. root 2 over 2. That's something I would just memorize. In a 45, 45, 90 triangle, in a unit circle, each side is root 2 over 2 and the hypotenuse is 1. The other triangle I would memorize is the 30, 60, 90. If it comes up. All right, and now tangent. Tangent, actually, somebody remind me, what's tangent again? Opposite over adjacent. Now that we've labeled all the sides in the triangle, we can find the tangent. It's always from the perspective of the angle tucked in by the origin. Always. Never from the perspective of the top angle. Okay, so let's do it. By the way, what side is opposite theta here?
Square root of 2 over 2.
Square root of 2 over 2. And now, the adjacent side, we've got to be careful. What do we have to be careful about because we're in quadrant 2? It's negative. Okay, so maybe you want to put that so you don't forget it. The adjacent side is negative root 2 over 2. Okay, once we simplify that fraction, we'll know what's inside this red box. We will know the answer. What do you get when you divide what I have written as that fraction? Negative 1. You're dividing two things that are the same. Except one's positive, one's negative. So now we know what the tangent of 3 pi over 4 is. Right? It's negative 1. So now our question simplifies a little bit to finding the answer to that. What is the inverse sine of negative 1? Now again, if they're saying without a calculator, then it's got to be something that comes out nice. All right, I think there's a couple ways to do it, but the easiest way to figure this out is think of the graph of sine. It looks like this. It's a wave. And what this question is asking is, where does this graph hit negative 1? First of all, how many spots does it hit negative 1 in that picture? Just once. It's going to hit once. Right there. That's 3/4 of the way through the wave. That's the beginning. That's the quarter, half, 3/4, all the way. If we go all the way, it's 2 pi. Halfway is pi. Does anybody remember what the 3/4 point was? Yeah?
3 pi over 2.
Exactly. If you're thinking in degrees, it's 270. That's what's between, that's the 3/4 point. If you're thinking in radians, it's 3 pi over 2. So we just answered the question without using a calculator. Again, that would only work if the answers come out very special. If this negative 1 came out to like negative 0.63, there's no way I'm going to be able to tell where I hit negative 0.63. It's got to come out to a 1, a negative 1, or a 0. Right there. Okay, so any questions on how we did that one? So it kind of combines a little bit of what we did back in chapter 6 with the unit circle. And then thinking about where the graph of sine hits negative 1. That's what that means. If you don't know the other triangle, let me sketch it right now. So the 45, 45, 90 we just did. Remember though that those root 2 over 2's can become negative depending on the quadrant. If you're in quadrant 1, they're both positive. Quadrant 2, x is negative. Quadrant 3, they're both negative. Quadrant 4, the y is negative. Okay, and then the 30, 60, 90. That's 1, 1/2, and square root of 3 over 2. Now, you don't have to pick these exact numbers, but these are the easiest ones to do because you're letting the hypotenuse be 1. In general, in a 30, 60, 90, the short side is always half the hypotenuse. So if you wanted to make the hypotenuse 10, you could then make the short side 5. As long as you make the short side half the hypotenuse, you just drew a 30, 60, 90. That's the relationship. But then if you change the hypotenuse and the short side, then you're going to have to use Pythagorean Theorem to figure out the long side. So if you just memorize these 3 numbers, you never have to use Pythagorean Theorem. Just memorize that triangle. Okay, so a little bit different when the inverse is on the outside. It's more of a calculation than it is algebra. It's like a numerical answer. So let's do this one. This is back to the type that we did before. Regular trig on the outside, inverse on the inside. What's different though is this is actually easier than the first problem I gave you. The first problem I gave you was a letter. Now I'm giving you the same thing, but it's an actual number. Okay. So we're going to start with the inside function. And from the first 2 examples, can somebody tell me what did we set that equal to? Theta. Theta. And then what's the next thing that I did?
Multiply by sine.
I liked the function you used, but what are we doing with it? We're canceling out inverse sine, so we're taking the sine of each side. Okay? Because multiplying you can only do with numbers and letters, and that's a function. So we're going to take and plug everything that's there into the sine function. We take everything that's there, and we're plugging that into the sine function. Think of the sine function as a box. You're taking everything that's in parentheses and you're throwing it in that box. And when you do that, that's what happens. So you get 1/2 equals the sine of theta. So now we need to set up a diagram where this fact is represented. So Wyatt, what kind of triangle am I going to draw? Well, we don't know anything about the angles. We have to be a little bit more general than that. Just what kind of triangle? Just a right triangle. We don't know if it's going to be a 45, 45, 90, and we never will in this problem. Okay. Does it matter where I put my point of reference? Where I put theta? No. Put it somewhere. Now, we know that the sine is equal to 1/2. So what 2 sides do I already know the length of?
Opposite and hypotenuse.
Yep, and in that order. Opposite and hypotenuse. So it's exactly the same thing you did in the first 2 examples, except now it's all numeric. Okay? How can I get the third side? Right, and I need the third side because the question is really asking me about cosine of that diagram. Well, for cosine, I need adjacent. Right now, I don't have it. So I have to use Pythagorean Theorem. So how about Ezekiel? Can you set up Pythagorean Theorem for me?
1 squared plus a squared equals b squared.
And now we're going to solve for a, and when we're done, we'll cross a out, and we'll put the value. So if I square it, Ian, what's 2 squared? 4. And how would I get that? 1 squared on the other side? Subtract it. So I get a squared equals 3. So Mike, how would I get a by itself?
You would square root both sides?
Yep. So a is the square root of 3. If you can figure that out without the Pythagorean Theorem, that's fine with me. If you need to do it, then that's how you do it. Okay, so now let's figure out the cosine of our diagram. Hannah, can you tell me what's the adjacent side here?
Just the square root of 3.
And we're going to divide by
Hypotenuse 2.
2. So the answer is square root 3 over 2. I'll take it. Any questions on it? And how would I know if you're doing it, if it says with or without a calculator? Well, I'm going to look for the work. I'm going to look, did you draw the diagram? Did you use Pythagorean Theorem to get the third side? And did you show me what I have exactly on the board right there? That's what you need to show. Okay, any questions on that? All right. Okay, so that's the first part. I think that's the harder part for today. The last part is solving equations. So keep in mind that when you solve a trig equation, it's different than solving an algebra equation like this. If I ask you to solve 2x equals 12, there's one answer. And that's it. You don't get many, many answers. You get one answer. When you solve trig equations, remember, a trig equation is periodic. That means there's a pattern to the graph that repeats itself over and over and over. So if you get a solution in one section, and the next section is a duplicate of that section, well, guess what? You're going to get a solution there too. So trig equations have many solutions. And remember to write the answer. You find all solutions in one period. And then on the end of each one of them, put plus the period times n. That's how you represent all solutions. Because if there's infinitely many, you can't write them all down. You need a formula to write them all down. It's like if I said to you, write down every even number in the world. You can't. But you could write a formula for all the even numbers in the world. N is an integer. 2, 3, 4, -2, -6. It's not a fraction or decimal. Calculator only has certain buttons on it. Okay, so if you have to do a problem with secant, cosecant, or cotangent, look at the calculator. There's no buttons for that. So the only way to type in like cotangent is 1 divided by tangent. Okay. So you might have to use one of those reciprocal identities if you have a problem with cosecant, secant, or cotangent. First one I do though, you won't need a reciprocal identity. I'm going to do one you got a button for, so it's pretty straightforward. Okay. Anyone still copying it? All right. Okay. So first one says sine of x equals 0.6. Okay, we'll do it graphically, and then I'll show you how you can do it still using the calculator, but then figuring out something a little bit on your own without the calculator. Okay, so what we're going to do is put that in y1. We're going to put the other part in y2, and we're going to look for where those two graphs do what? Yeah, we're going to look for where they intersect. Put sine of x, 0.6. It's not super important I close the parenthesis because I didn't have anything coming after it, but if you want to close it, go ahead. Okay. Now, what's the period of sine? Like normally you have to go from 0 to this, to 2 pi. Right now, I'm going negative 10 to 10. That's not good. Let's go from 0 to 2 pi, and you're going to see exactly one wavelength. As far as the highest and the lowest, what's the highest and the lowest that sine normally goes? Negative 1 to 1, so negative 10 to 10, that's more than you need. Let's go negative 2 to 2. Here's your sine wave. You're going to see perfectly one section. In a second, you'll see a horizontal line at 0.6. And now the directions say, find all the solutions in one period. So let's start with that. Second calc, intersect. Does the guess matter?
Yeah.
Yes, because there's two answers. So whichever one I'm closer to, that's the one it's going to give me. So I got 2.498. That's the first, well, technically that's the second answer. Let's go get the first one. It doesn't matter the points you pick on the curves, it just matters where you put the guess. So let's try to get closer if you can. That should be good enough. Okay, 0.644. And now, each one of those answers is going to occur again. It's just off the screen. You can't see it. But how far later is the answer going to occur? The next period over. So the way we write our answers is put plus period times n. So plus period times n. So if you wanted to know, well, where does this 0.64 answer occur again? It's going to occur again 6.28 units to the right. And 2.498, that's going to occur again, another 6.28 units to the right. That would be the next two. And then again after that, another 6.28 units, okay, forever. Okay. Any questions on that? All right, so if we look at this, we've looked at things like that earlier. How can I get rid of sine here and get x by itself? What do I have to do to get rid of the sine function? Take the inverse sine. So watch what happens if you take the inverse sine of each side. Do it on the left, you get x. Do it on the right, and you get inverse sine 0.6. 0.644. 0.644. That's one of the answers we got doing it on the graph. So you can get one of these answers without graphing it. Just take the inverse sine of each side to get x by itself. But the question is, where does that 2.498 come from? Like, numerically, how did that one come up? That one, people remember this diagram? So we did that, I don't remember the exact section, but this tells you where the trig functions are positive. In quadrant 1, trig functions are all positive. So if we were doing this in degrees, give me any angle you want between 0 and 90, and if you take the sine of it, the cosine of it, or the tangent of it, it will always come out positive. Quadrant 2, that covers numbers between 90 and 180. If you give me a number between 90 and 180, I guarantee you if I take the sine of it it'll be positive. If I take the cosine of it, negative. Tangent, negative. If you give me a number between 180 and 270, the tangent will be positive. And that's it. If you give me a number between 270 and 360, the cosine will be positive. Everything else will be negative. So that's a hint at where the second answer is coming from. Sine equals 0.6. What kind of number is 0.6? Positive or negative? It's positive. It's positive, and the problem had sine in it. So that tells me I'm going to get one answer here, and the other answer is going to be here. Okay? I'm looking for where sine is positive. It wouldn't be in quadrant 3. That's where tangent's positive. It wouldn't be in quadrant 4. That's where cosine's positive. The calculator always gives you the first quadrant answer. And if you're like, well, wait, how is 0.644 an answer? Well, remember, that's in radians. So if you're thinking of these numbers in radians, that's 0, and that's pi over 2, which is about 1.57. So in radians, it's not 0 to 90, it's 0 to 1.57. 0.64, that's definitely between 0 and 1.57. Second quadrant, 180, that's the same as pi. What's pi as a decimal? 3.14. So when you're dealing with radians, the second answer is going to be between 1.57 and 3.14. Look at the answer I have, 2.498. Definitely between 1.57 and 3.14. How did we get exactly 2.498? Let me show you. If you take pi and you subtract the first answer you had, 0.644, 2.498, 2.498. So it turns out the second answer was pi minus the first answer. Is it always pi minus? No. If it's in the second quadrant, it is. If it was in the third quadrant, it would be pi plus. So if we were dealing with a problem that had tangent, the second answer would be pi plus. And in the fourth quadrant, it's 2 pi minus. Okay? So still, to get the answer, though, you have to use the calculator, okay, to get this. We can't get that by hand. Okay, so you've got to use the calculator to at least get the first answer. And then once you have the first answer, either subtract it from pi, add it to pi, or subtract it from 2 pi. Depends on what quadrant you want the second answer to be in. Okay, so we'll try that again. It gets a little, you just have to get used to using the diagram, but it's not really too bad once you know how to use it. Okay, let's try this. Cotangent x equals 2.5. Okay, cotangent, we have a button for that on the calculator? No. So how can I type in cotangent? Right, I've got to rewrite this problem like this. That's how I have to type it in. All right, so let's do 1 divided by tangent. And let's put 2.5 in y2. Now, cotangent and tangent, they don't have a period of 2 pi. They have a period of 1 pi. Okay, so when we set our window, if you go 0 to 2 pi, watch what happens. You're not going to get just one section. You're going to end up with 2 sections. That's not what you want. All you want to do is focus on one section of tangent, or cotangent. So what I'm going to do is pretend I'm going to get rid of that second one. Okay, so if you need to write that down again, tangent and cotangent have a period of pi. Everything else is 2 pi. So let's go 0 to pi. Now, I didn't see my horizontal line because look where the horizontal line is. It's at 2.5. My max value is 2. It's not high enough. So let's put it up at 3. Now when we sketch it, I'm going to see a horizontal line right there in a second. Okay, so there's my solution. Now, this time, how many answers are there?
1.
Just one. Okay, there's just one answer. So we wouldn't have to worry about doing all this. Well, where's the second one? There isn't one. So that doesn't apply in this problem. So all we're going to do is do second, calc, intersect. The guess doesn't matter because if you put it anywhere you want, it's going to find the only intersection that's on the screen. And it's 0.381. Now 0.381 is the first solution. How many units later is the next answer going to be? Pi units later, exactly. So had I left that other graph on the screen where you could see 2 of them at the same time, the next solution would have been 0.381 plus 3.14, whatever that comes out to. Any question on that one? All right. Let's do one with cosine. I'm going to do 0.7. Okay, without graphing it, can somebody tell me what I would have to do on both sides to get x by itself? Take the inverse cosine. Do it on the left. Do it on the right. Let's do it out and see what we get. Cosine equals 0, the inverse cosine of 0.7. Second, inverse cosine, 0.795. I would argue that's faster than graphing it. Because by the time you graph it, set your window, calculate and intersect, I think I'm probably already done. 0.795. Okay. Plus, don't forget your 2 pi in. Now, with cosine, there would be a second answer. Think of the wave. And think of a horizontal line. The horizontal line always hits it twice when you have a wave. Tangent's not a wave. That looks like that. That's a little different. Let's think of our diagrams. 0.795. That's the first answer. You just found that one. The original problem was cosine equals 0.7. What kind of number is 0.7? It's positive. What other quadrant is cosine positive? 1 is where sine is positive. 4. That's your second answer. It's in quadrant 4. And what did we say to do if it's in quadrant 4? Subtract the answer you just got from 2 pi. Okay, let's do that. Let's just take 2 pi, so 2 times pi, and subtract 0.795 minus 0.795, 5.488. Okay, I'm going to double check that by graphing it calculating the second intersection and see, is it really 5.488? So we got cosine, 0.7. Okay, let's see. So we know we're going to get a horizontal line. I didn't fix my window. What's the period for cosine? 2 pi. I'm only looking at pi, so I'm only drawing half the picture. If you set the wrong window like I just did, you might think there's not a second answer. You've got to remember if you're supposed to set it to pi or 2 pi. Okay. So trust me, that first one, that's the 0.795. Let's calculate the second one and see if it's 5.488. Intersect. Just get a little closer to it. You don't have to be right on top of it. Just a little closer is good enough. And I don't know if you can see it or not, but that does say 5.488 if you round. Okay, so this diagram, if you don't have it, very important. This ASTC diagram. Okay, so again, if you watch the first part of the video, I don't know how long it was, maybe about 10 minutes or so, there's no sound. But then everything after that has sound. Okay, that's a good place to stop today. So 394, not too many questions, but 37, 38, 41, 42, 45 to 47, and 49 to 53. So we'll take a look at that first thing tomorrow. And then we'll do 7-3, 7-4 on Tuesday, Wednesday. And remember, Thursday this week is going to be a review day.